The last part of this session is looking at variation problem. So for the variation problems, you want to pay attention on terminology, which is varies directly and vary inversely. If I say that y varies directly with x, that is basically y is equal to k times x. If y is very inversely, then we are basically talking about y is equal to k divided by x, the inverse variations. And k is always a variations of constant of variations, and which we need to look for that. So in the problems, it's always going to give you two sets of information. The first set of information will allow you to find this variation of constant. And then on the second set of information, one of them will be missing, which they're asking you to look for it. So first thing that we need to do is write the variations formula and then substitute the first set of value to find out the k, and using this k to answer the remaining questions. So let's take a look at on the first example. The numbers of calorie burns vary directly with the amount of time spent exercising. So in this case, it is talking about what? The numbers of calorie burns, right? Varies directly with the amount of times what? Spent exercising. So this is telling you how to set it up the formula. So what we need to do is like before, defining the variables. Because you need to exactly tell me what your x, y, z represent. So first up, I would say that let n be equal to the numbers of calories burns. Okay? And then t will be equal to the time spent exercising. Now that I got this already, and then this is how I usually teach on my second step and the third step, the T chart. We're going to write down the formula. The formula said that the numbers of calorie burns vary directly with the amount of time spent exercising. So that means the numbers of calorie burns is equal to k time, because of the direct variations, k time amount of time that you spent. That will be the set apart. Now, the first set of information tells you the numbers of calorie burn is 312, and it will take the times to be what? 65 minutes to exercise, to take that much burn. So from this first set of informations, now I can find out my k, because notice that in the formula, we only missing k now. So plug it into the formula, that will become 312 is equal to k times 65. And if I divide both sides by 65, okay, which is 312 divided by 65, that gives me 4.8. Now we know the k already. Continuing the questions, how many calories will be burned if he exercised for 90 minutes? So the next question is asking you how many calories will be burned. That will be my n will be question mark. And then if you exercise 90 minutes. So k, we can use the k that we just found, which is what? 4.8. Now, finally, we can answer the question that asking, right? My n will be equal to 4.8 times with 90. And therefore, my answer n will be equal to 432. And then my interpretations will become 432 calories burned for exercising 90 minutes. That will be my final interpretation. So use this T chart will help you to nice and neatly complete separate the two informations. So let's try another one. The numbers hour it takes to it takes for ice to melt vary inversely with the air temperature. Suppose that a block of ice melts in 2 hours when the temperature is 65 degrees Celsius. How many hours would it take for the same block of ice to melt? The temperature was 78 degrees. So after we read the whole things, we know that we are talking about the numbers of hours takes an ice to melt is very inversely with the air temperature. So my unknowns in this case will be 1. I can say that let T be equal to the numbers of hours and temperature, air temperature, right? Uh, let's say uh, A, the air temperature. So let A be equal to air temperature. And in my second step, we're going to write down the formula. The formula said that the numbers of hours, which is T, vary inversely, that means equal to K over the air temperature, which is K. Now, the first set of information, it said that when the time it takes 2 hours to melt a block of ice for the temperature of 65 degrees Celsius. So therefore, I can find out what is my constant variations K. So plugging into the formula, the times 2 is equal to K over 65. And then if you multiply both sides by 65, that will give me 130. So now we know K's already. Now, using this K to find out the rest of the information, it tells you how long does it take, right? It's asking you to find how long does it take. So my T will be question mark when the air temperature is 78 degrees. And then we know that the K will be 130 because it's the same block that we talked about. So plug it into the formula, that will be T is equal to 130 divided by 78. If you use the calculator, 130 divided by 78, that will come out approximately 1.666, so it will be approximately 1.7 hour. So now I can interpret it. It will take 1.7 hour if the temperature is 78 degrees Celsius. And this will conclude this session.